In this video, we will see vector section formula and its applications. The section formula for internal division says, let O be the origin. So, O is an origin. Let A and B be 2 points. A and B are 2 points. Let P be the point that divides the line segment AB internally in the ratio m:n. So, the point P divides the line segment AB internally in the ratio m:n. If vector A and B are position vectors of A and B, so vector A and vector B, these are the position vectors OA and OB. Then the position vector OP of P is given by this formula, which is we need to prove that this vector OP is given by this formula where m and n is the ratio in which P divides AB. Okay, let's proceed. So, putting things in order, since O is the origin, A is vector A and vector B are the position vectors, we can say OA is equal to A and OB is equal to B. And let's define OP as vector R. So, I have defined OP as vector R. Okay. Since P divides the line segment AB internally in m:n ratio, so P divides AB internally in the ratio m:n, we can say the magnitude of AP divided by the magnitude of PB is equal to m by n. So, there's a vector sign missing here. Okay, so the ratio of the magnitude of AP over the magnitude of PB is equal to m by n. That's very simple. So, cross multiplying n this side and bring the vector PB this side, magnitude of PB this side, you have n times magnitude of AP is equal to m times the magnitude of PB. Okay, but the vectors AP and PB have the same direction, right? Because AP and PB, they have the same direction. I hope this is clear for you. Okay, then we can also say that AP, which is this AP, is equal to OP minus OA. How can we say that? Let's say we know that the vector OP is equal to OA plus AP. Okay, vector OP is equal to OA plus AP. So, rearranging this formula, AP vector is equal to OP minus OA. So, we have that here, AP is equal to OP minus OA, and we have already defined our OP to be R. So, that is R minus A, vector R minus vector A. And similarly, we can prove that PB, which is this PB here, is equal to OB minus OP. Like how we proved here, we can also prove this. And our OP again, replacing it with R and OB with B, you get this result. Next, substituting the values here in this, what we derived here, n into AP vector, and our AP vector is R minus A. So substituting it here, n into r minus a is equal to m into pb, which is pb is b minus r. So m into b minus r. We can further derive that, rearranging this, bringing this to the other side, we can say n plus m times the vector r is equal to n times vector a plus m times vector b. And if you bring this down to the other side into the denominator, r vector is nothing but op. So the vector op is equal to n into vector a plus m into vector b divided by n plus m. And therefore, we have proved that our vector op, which divides ab in the ratio ms to n, can be defined as na vector plus mb vector divided by n plus m. We will have a short glance at the section formula for external division. So when I say external division, the point P is not internally dividing it, but the point P will be somewhere here or somewhere here. So for understanding, let's draw this something like this, and this will be a continuous line here. So this will not be our P, but our P will be here. So P, OP, or rather P, the point P, will externally divide A and B in the ratio ms to n. So in that case, we can still prove that OP is equal to, this OP is equal to NA vector minus MB vector divided by n minus m, where our A is OA vector and B vector is OB vector, and m and n is the proportion in which it will divide externally the line segment AB or the vector AB. Further, we can derive that if m is equal to n, then according to our theorem, we can say that our, this is our theorem, which is OP is equal to n A vector plus m B vector divided by m plus n. But since m is equal to n, you will replace n and m with 1. So you'll be left with, so this will become A plus B divided by 1 plus 1, because our n is 1 and m is 1. And in such a case, P will divide the line segment AB exactly into two equal halves. So you can call P as the midpoint of the vector A and B. And then the vector OP, which divides AB exactly into two equal halves, or it meets AB at the midpoint of AB, can be defined with this formula. So further, this is vector A plus vector B divided by 2. So this is our midpoint formula for a position vector. Okay. So further, we can infer that three distinct points A, B and C with position vectors A, B and C are collinear if and only if there exists real numbers x, y, z, none of them is 0, such that x plus y is equal to 0 and xa plus yb vector plus zc vector is equal to 0 vector. This is our formula of the position vector. So we can OP vector into n plus m is equal to n A vector plus m B vector. Rearranging this, OP vector into n plus m plus minus NA vector minus NB vector MB vector is equal to 0. Okay, moving these two to the other side. So we can say n plus m OP vector plus of minus n A vector plus of minus m B vector is equal to 0. So here our x is equal to n plus m, y is equal to minus n, z is equal to minus m. So adding x plus y plus z, we get n plus m minus n minus m, which is equal to 0. We can try and do a sample problem now. So let's see this problem here, which is let A and B be 2 points with position vectors 2a plus 4b and 2a minus 8b. Find the position vectors of the points which divide the line segment A and B in the ratio 1:3 internally and externally. Okay, so we have two cases, one that divides it internally and second is divides it externally, and the ratio is 1:3. Okay, so we're going to define the two vectors. So let's say that this is OA and OB. So we have to now find the point P, one which divides it internally and the other one which divides it externally, and the ratio is 1:3. Okay, right, let's proceed. So we have our formula for if it's internally divided, it's this is our formula. So where n is equal to 1, m is equal to 3 here. So we can say that 3 times OA, which is our vector A, plus OB, 1 times OB is equal to 3 plus 1. So which is actually our n is 3 here and our m is 1. Okay, and let's substitute the value of vector OA, which is this, and vector OB, which is this here. So 3 times of 2a vector plus 4b vector plus 2a vector minus 8b vector divided by 4, and that would be equal to 6a vector plus 12b vector plus 2a vector minus 8b vector divided by 4, and that's equal to 6a plus 2a will be 8a vector, 12 minus 8 is 4, 4b vector divided by 4, that would be 2a vector plus b vector. Similarly, for external division, if the point P lies outside and divides it in the ratio 1:3, then this is our formula. So applying this here, 3 times of 2a vector plus 4b vector minus of 2a vector minus 8b vector divided by 3 minus 1 is equal to 6a vector plus 12b vector minus 2a vector plus 8b vector, and that's divided by 2. This is equal to 4a vector plus 20b vector divided by 2. That gives you 2a vector is 20 plus 10b vector. So that's our two vectors, which is OC and OD, which internally and externally divide the line AB in the ratio 1:3. Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.